Hello everyone, and welcome back to another episode of Advent of Code programming. This is going to be for day 7, although this is not a live event. I'm recording this and we'll upload it later. Probably we'll be doing the same thing tomorrow night as well. Might be able to get back to live streaming for day 9 and later, but not for days 7 and 8. Anyway, we're, I believe, all set here with Emacs and our shell, ready to do any editing, which is, of course, most of the point. And the problem has already long since been posted, so let's just go have a look at it. Internet Protocol version 7. Nice. IPv6 has expired, yeah. IPv7, I like it. IPv6 is much too limited, yeah. The local network of the Easter Bunny headquarters, alright. Compiled some IP addresses. An IP supports TLS if it has an autonomous bridge bypass annotation, or ABBA. Okay, sure, ABBA. An ABBA, or an ABBA, is any 4-character sequence which consists of a pair of 2 different characters followed by the reverse of that pair, such as XYYX or ABBA. However, the IP also must not have an ABBA within any hypernet sequences which are contained by square brackets. Okay. How many? Yeah, alright, fine. So we're looking for we're looking at IP addresses, and we're trying to break them into hypernet sequences, which are in between brackets, and non-hypernet sequences, which are not between brackets, and then scanning each of them for ABBA sequences. We need there to be at least one outside of square brackets and none inside of square brackets. So the first question which occurs to me is, do we need to worry about square brackets that don't balance? Oops, highlighted a little too much there. AA is invalid. The interior characters must be different. Okay, it's fine. So let's look at some of these example inputs. And we'll search for, like, I don't know, I mean, we could, I suppose, do this in a more principled way by writing a program to detect if this is, if these are balanced. But I gotta say, they look fine to me. Okay. So what is our plan of attack here? Well, first, let's download all these IP addresses and put them into our input file. And so one thing we could do is we could solve this pretty simply, I think, with a couple of regular expressions. It's not hard to break the string apart by hypernet sequences, I believe. We could use split with a regular expression that is one that recognizes an open square bracket followed by a closed square bracket. I'm not sure exactly if that would give us the delimiter as well. When you call split in Python, do you get the delimiter? Probably not. There's probably no easy way to get it. But what we could do is just split it by either an open bracket or a square bracket. However, so in that, right, that way, like, oh, okay, if you split this, like, say we look at this first one. I say, if we split, phew. That one made me nervous, but that's because I thought it started here, and I was like, wait a minute, this isn't balanced. But no, there's a matching square bracket on the previous line. So like you can imagine, let's say we were to split at this, then like the first one would be a non-hypernet, and the second one would be hypernet, and then this one would be not. And we could just sort of alternate whether we're checking for or invalidating based on at each of these things. However, there is the question of what if one of these things starts with a square bracket? This one doesn't, although it looks like it does. So let's do a quick test for that here. We'll grep for a line starting with a square bracket in input.text, and there aren't any. Okay, so we can reasonably just split on either square, open or closed square bracket, and then alternate modes back and forth. And within each one, there's a not too complicated regular expression that will search for these. What are they called? ABBAs. That seems probably fine. I wonder though, like if that's design-wise. Have you guys? Anyway, you guys have still been staring at the input when I typed something into grep, but it wasn't anything very exciting. So too bad. Here you go. This is all I typed. Searching for lines that that start with a square bracket, and there weren't any. I wonder though. So like, okay, say we did this, we would have a list of lists of strings, or a stream of lists of strings anyway, and we could just iterate over them and produce either true or false, and then filter and count or whatever, right? But that leaves us probably somewhat ill-prepared for part 2, where I suspect we may be asked to answer some other kind of question about the hypernet sequences. So I'm thinking it might be interesting to start by parsing an IP address into a class that is like, that has, I don't know, a list of instances of like hypernet and non-hypernet. Yeah, I don't know. I don't see exactly how that's getting us any better versus just having a list of stuff. Because there's not any obvious kind of dispatch that we want to do based on that, I don't think. All right, so let's just try the straightforward thing and see what happens. So what we're going to do is write def parse IP to take in a line and return line.split of, God, how do you Python split line, split string, I should say. Well, there's a string split method. Is it a method or a function? I don't know. I can never figure it out. Apparently, it is a method. Oh, but we have to. That won't split on regular expressions, or even on like groups of different delimiters. So we have to write Python regex split. Regular expression operations. Search split takes a re.split takes a pattern and a string. Okay. Re.split of. Now this is one of my favorite regular expressions, by the way. Just, well, because it's so silly. But it's actually valid, believe it or not. in like PCRE flavors, which I believe Python is. And we'll just write line, line here. And then I'll explain, so what is the other argument here? Flags? I don't need any silly flags. Okay, so let's call this IP parts or something. And let's test this, see if I'm right. IP parts of, say this. Import RE, I guess? Yeah, it seems like that worked. Cool, so it did work. Now, there's an interesting thing here. Why is it not? I'm surprised that my highlight next expression thing doesn't think this is an expression. I guess it doesn't know we're in Python mode down here. Weird. All right. Well, but in fact, it did work, right? We have this, which is a non-hypernet sequence, and then this, which is, and then there's this this one that's empty. So we don't want that. So let's just call filter len of this, and that should work because len of 0 is false and len of a thing is, or 0 is falsy. Whoa, why did, okay. How about this? Yeah. So this would be a problem if we had any lines that started with a hypernet sequence, but we checked and we don't, so there you go. So what the heck is the deal with this regular expression? Why does this make any sense? If you're familiar with regular expressions, you should know, or maybe know how to look up, that this square bracket, so a group of square brackets is a capturing group. Geez, what am I saying? Not a capturing group. It's a character class. So like A, E, I, O, U is a regular expression that matches one or more vowel in a row. Okay. But what is the deal with this? That's an empty character class. It can't match anything. That's true. So why does having two of them make it better? Actually, it's not true. This isn't an empty character class because it doesn't make sense to have empty character classes. What would they do? So it's actually illegal to write one. But what we've written is not an empty character class, although it may look like it. Consider, what would this mean? Well, there's a start bracket here, so we must be starting a character class. And it doesn't make sense to have nested character classes, so the character class includes a left bracket. Okay. And then we get to a right bracket, and it's like, all right, well, the character class is over. We can go home. It's a character class containing just the single character left bracket. And that's equivalent to this, escaping the left bracket character. So you could do either one of those, and this is usually more readable. But okay, well, what about this now? What does this mean? There's a start bracket, so we're in a character class. There's an end bracket, but it's illegal to have an empty character class because those don't make any sense. So this must be the character class contains a right bracket. Okay. Now we get here, and oh, well, this isn't an empty character class, so it's legal. So this is, actually, let me put a comment here. This is the same as this, and this is the same as this. And so it turns out that you can write, this says, okay, the character class should have a right bracket in it, and this says, oh, the character class better have a left bracket in it. Aha, now we can close. And that's the character class that's, so that's equivalent to, something like this, right? The non-capturing group containing either a left brace or a right brace. So for these two cases, at the beginning, it's really a lot nicer to write, I think, just this. So no one has to figure out what the heck your weird this thing means. But when you're writing both of them, I think it's more readable. There's just less stuff to parse, and as long as you understand how character classes work, it's not too surprising what this is. Anyway, so all that's an exciting lesson. But if you've seen it before, I hope you don't mind that I went through what this is all about. Okay, so great. We've parsed all the things, and now we can easily write def accepts TLS of an IP, and we'll say has ABBA. Actually, let's write def contains ABBA IP part to be return re.search. How do you call search? Search takes a string first. Wait, am I crazy? Yeah, re.search takes a pattern first. Okay. So the pattern here is going to be something like we want. Oh, we're using single quotes for these. I don't know why, but people do it. Maybe it's good style. We want a regular expression that matches some character. So by the way, this expression is not by the formal automata theory of regular expression, is not by theory a regular expression, if you're going to use back references, which we are. It requires a large... What is the... A regular expression recognizes a regular language, and that means it has to have a finite state space. But because we can put like any character at all, I mean, okay, yes, it's finite because our computer has a finite amount of RAM, but in principle, if there were an arbitrarily large language of characters to recognize, this would require too much state space to count as regular language. Anyway, so what we're going to do here is we're going to match some character, any character at all, and we're going to save it as a back reference. And then we're going to match almost any character, except that it can't be... Does that actually work? Can you put back references into character classes? I'm going to go with probably not, actually, right? Character class back reference, PCRE. Equivalent of back... Okay. So someone's asking if you can do this, and if not, what you should do instead. So we could do it with look around. Yeah, that's what they're saying. Do it with negative look ahead within a repeated group or something like that. Okay. So we can't actually do a negative character class like this. Instead, what we need to capture is something that is not the same as our square... as our first thing, but is any character. And then match this. So that should be exciting. What happens... Oh, I don't know, it's just equals false. All right. So let's say I were to write has ABBA of ABCD. Oh, that's not what I called it. I called it contains ABBA. Search takes at least... Oh, of course, we need to pass the IP part. Why have you just returned to me the text that I typed in? That is baffling to me. I defined this function, and it's calling research on like a string and returning that, but then Python is just telling me it's this. What the heck is that all about? What is the type of that? None. So why is this printing? It should print none, I thought. Maybe I don't understand the Python REPL? What if I do Python in a real REPL, not in Emacs? Like, let's find something that might be... That's one way that I could be doing things wrong, is doing something wrong and not understanding the Emacs bridge, or the Emacs bridge isn't working or whatever. So there it returns none. Okay, so when that doesn't surprise me. When the REPL encounters none, it instead of printing the return value as it does for every other value, it just displays nothing at all. That makes sense to me. And I guess that Emacs chooses to instead print the value you typed in. Okay, weird. But I guess I can live with it. So what if we then write A, B, C, D, D, E, E, F, G? Does this... This doesn't work either. So there's something wrong with... Oh, I think I need to question not equal, right? Maybe I should try this in Perl first. Because I know what Perl regular expressions look like, and I never quite know what flavors are supported. Oh! I bet we need more dang backslashes because we're inside of a Python string. Although I don't know. I bet Python's R quote understands about all that. Let's try re.search of B for something like this. So that returns a match. Okay, so that tells me that I am wrong. It does not understand that this back quote. All right. So we do need to add more of these, I think. Maybe that's not the only problem, but it certainly was a problem. Huh. Well, that's what I get for saying it would be easy to do with regular expressions, huh? All right, let's try this. Perl dash n dash e print if m slash this is what I believe to be the right regular expression. Like so. A, C, B, B, E, E, D. That does not print, so I am clearly incorrect about what this regular expression is doing. Why? Oh, maybe I wasn't supposed to... I always forget when you need these equals. I bet we don't here. No. Well, okay, let's try another experiment. Now, we could do this without regular expressions, but I kind of would like to understand what it is that I'm getting wrong here. So what I'm going to do is, where is that? Is it like regex buddy online thingy? Like, what is that called? I know there is one. And it's not called Regex Buddy, although Regex Buddy is good. Okay, cool. So let's show you guys this, right? You are able to look at this now? You are. Very exciting. And let's erase this and paste this. Now, what's wrong? Oh, well, there's a slash there. How do I... Tell me what this means. Do I need a wider screen to see this? Yes. Please, if you're building a website, it would be real great if you could allow, like, I understand if the sizes that I browse at, like, stuff doesn't necessarily display. But please don't take away horizontal scroll because you think it's ugly if it makes it impossible for someone with a less than 4K monitor to view your page. That's my opinion. So how does this work? Like, I know what this all says. Groups multiple tokens, yeah. This is a match a character, yeah. This is a capturing group. Negative look ahead. If it does match, the result is discarded. So we're capturing this. Oh, son of a... I'm so dumb. I didn't read it. I didn't read the regular expression that I wrote. It should be 2 and 1. Gross. All right. Let's try this. All right. And does it turn out that I am wrong about these backslashes after all? No? I'm still not seeing anything. Oh, that's because I've been typing in the wrong thing here, too. Jeepers creep. Have I? D-E-E-D. Yeah! I've been typing in the wrong thing. It was probably working forever ago. Yeah! Ugh! Alright, so, you remember like when you were back in school, right? I don't know. I guess this probably didn't happen to too many people, actual people. But there's an urban legend about like a teacher who hands out a test and the test says to do like all this outrageous... It's like, please read the instructions carefully and then read all the instructions and do the blah, 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 blah. And it contains like these ridiculous instructions like, hoot like an owl 5 times or whatever, right? And then the last instruction is like, actually don't do any of the previous stuff, just put your name on the test. And it's like a test to see if you actually read the instructions before starting the test, right? Not a real good actual test, a mildly funny story. But a good lesson is that, like, I don't know, just read things? Ugh. So, that was the problem. We had the 1 and the 2 backwards here this whole time. Very, very funny. Lovely, lovely stuff. Okay, so now we have this. And what we're going to do is, what? Let's just write while IP, and we'll modify IP in place. That's the Python way, right? I think. Sure. And we'll also write want ABBA equals true. And then while IP, if contains ABBA of IP 0, so then we'll say, okay, we found it. We found a match. If not want ABBA, so is this a thing you can do? Can you write this in Python? Is this legal? No. That's like a Ruby/Perl thing. All right. Return false. So what I'm going to do is at the end of every loop, I'll skip one section of the IP, and I'll also invert whether or not we want ABBA. So if we see an ABBA when we don't want one, then I'll just say, nope, this definitely doesn't match. And if we see an ABBA when we do want one, I'll say, yes, this qualifies for a match, even though it may not necessarily match. So actually, we should do it this way. If want ABBA has ABBA equals true, else. Okay. We could avoid the else if we inverted it, I suppose, but I think it's more clear this way. And then we'll just say IP equals IP of everything starting at 1, and want ABBA equals not want ABBA. And then at the end of this, we'll just return has ABBA. And let's implement, not implement, from iter_tools import ifilter. How do you, is it iCount? Oh gosh, dang it! You guys have been looking at the whole classic Amalloy stream. I forgot to go back to Emacs when we were done debugging the regular expression. This is why I shouldn't ever put more than one window on screen. I've recorded a number of things before, but this is the only thing where I regularly switch windows, and so I'm just not used to doing it. So what I fixed was this \2\1 here. I had typed it the other way around, matching 1-2 instead of 2-1, and like that was the only problem. And it just took me forever to figure out what was going on. I guess there was also the problem that I had forgotten this equal sign for a while, but we fixed that while you were watching. And in the meantime, I wrote accepts TLS for an IP. And you guys were listening to me write it, and we'll see how clear my explanation of what I was writing was. If you imagined crystal clear in your mind exactly what I typed, then I did a great job narrating. And otherwise, we'll briefly go over it again. Basically, we're iterating over the IP string, and as long as it's non-empty, we check the first segment to see if it has an ABBA. If it does, and we're in the mode where we're looking for ABBAs, then we make a note of it and say, lovely. If it has one and we're in the mode where we're denying matches for having ABBAs, i.e. inside of a Hypernet sequence, then we immediately return false. And then at the end of the loop, we throw away the first list item of the list, and we flip which mode we're in. And at the end, we just return whether we ever successfully made a note. And I was in the middle of importing ifilter, and I was going to go look up how you count Python count. Oh, speaking of, my window is now wider than my screen because I had to widen it for that dang web page. Python count iterator. Getting number of elements in the iterator. Yes, I know that you can't like just call len, but oh, that's right. Everyone writes like sum of 1 for ugh. All right, well, we'll just do some. I don't know, do something else. We'll just use an actual filter instead of an ifilter. We won't use streams because Python makes streams hard to use. It's so nice in Clojure. Okay, having a type which is lazy, just like an iterator is, so you can process it lazily, but which also caches the results for you if you keep a reference to them, so that you can use it both as an actual list and as a stream, rather than having like a completely separate set of operators for operating on streams, for operating on lists, for operating on dicts. They're all just like one thing, and it's real great, and it's annoying in Python having to like change my entire program if I want to use a stream instead of a list or vice versa. So what we're just going to do is we're just going to print sum of 1 for x in, well, no. Let's just for line in sys.stdin. We'll do it the baby talk way here. Valid equals 0 if accepts TLS of IP parts of line.r strip then valid equals valid plus 1, and then we'll print valid at the end here. So how's that going to look? Python source.py on input. Cannot import filter. Well, it's ifilter, which I was going to type, but then I decided to use a list, and then I forgot. All right, there's 117. That's not the right answer. It's too high. Interesting. Well, there are 2,000 lines in the input, and we decided 117, which was too high. Interesting. What could have gone wrong? All right, well, let's do some testing. Except, well, what could we do? We could print line. And this will tell us, we can see all the ones that matched, right? And we can just sort of inspect one at random and see like if there was a problem with it. Kind of hard, actually, to just see these and try to figure out like what was going on. Like here I see this FMMF, so that one qualifies, and this is the only thing that could make it not qualify, but there's no problem here. So that one was correct. How about here? I see a PDDP, so that's good. How about inside? I see a GG, that is a JIJI, but that's not a problem. IKKO, I mean, it looks fine. How about here? Don't see anything in this one. This one, there's no double letters in here at all. There doesn't seem to be anything interesting going on in this segment. How about here? Any double letters at all? No, not in that part. Here, I don't see one, right? How about this? No, but then there's this IZZI. So this one looks legit. How could we get some more information about the lines that are being accepted? We could put some more printing into here about when it's aborting early and when it's accepting. But those would print on all 2,000 lines, not just the 17 that are accepted. So that doesn't seem like a good plan. Boy, how are we doing for time? Seems like this one's been going on for a while. Well, I don't know. Something's wrong and it's not showing me my timer status bar. Can I view status bar? Yes. Okay. 40 minutes. All right. Well, this is... we certainly struggled with a lot of dumb stuff. That's for sure. But now we're at, I don't know, sort of a point where something is wrong with probably our algorithm, although it'll turn out to be something dumb. It always does. What can we do? Okay, so what we could do is return a little bit more information. No, that won't help, will it? I was thinking we could return why things are being disqualified, but that wouldn't help us because too many of them are being accepted. Now, like, we could sort of guess, right? We could say, 117 was too high. There's probably not that many edge cases. Let's try 116. But that's not a very good plan. How does our regular expression behave on strings of fewer than 4 characters? It seems like it behaves in the correct way, right? It just doesn't match them because we have 4 parts of our regular expression, each of which must match exactly 1 character. So I think we're okay on that front. It's possible that we have some regular expression, some inputs that don't match our expectations about having balanced square brackets. Could we test that? Yeah, it wouldn't be too bad, right? We could run a grep against the input, like for a square bracket followed by any number of characters which are not open square brackets, or which are not closed square brackets, I should say. Star. And then another open bracket. None of those. So there's no case of an open bracket followed by another open without a close. How about a close followed by not an open and then another close? No, there's none of those. How about an open followed by any number of non-closes and then the end of the string? No. So they're all properly closed. Are there any that open? Like let's see. Beginning of the string. Wait. This caret at the beginning of the string that I did not realize was there has invalidated all of my searches. I forgot it was there. So I want to try running these tests again without it. Perhaps unsurprisingly, it's fine. But now I actually do want one. Do we have any things that are not an open bracket star followed by a close bracket? No. Okay, so our input all conforms to expectations. It's all well-balanced open and close bracket pairs. So that's not the problem. What about if there were a completely empty escape sequence? So we're sort of looking for, well, actually I don't want -p really, but whatever. What if we're looking for something like this? There's no instances of an open bracket followed by a closed bracket either. So that's not the problem. So our input seems to be shaped as we expected, but we're not getting the results we wanted. We could sort of speculate about what could be going wrong. What I'd really like to do is come up with a way the computer could detect, could give us more information about what's going wrong. You could imagine running this in a debugger, perhaps. Um, hmm. It seems like. Is there any way that the problem could be in IP parts? I think the answer to that is no, because we have. We've checked our input, and we know it contains well-balanced, non-empty non-empty parts, and they're not. Except there are some empty ones at the end, but that's okay because we're just throwing those away, and that's fine because empty strings can't ever have ABBAs, so it doesn't matter what mode we think we should be in when we find them. Or it wasn't even empty, was it? It was at the end, I think. Anyway, and we have convinced ourselves that this split will always work for input within those constraints. So, could the problem be in contains ABBA? Maybe. We certainly had some difficulties with that expression earlier. We know that the input contains no new lines because we called line.rstrip already. So the regex definitely, we're calling search, which scans through the whole string, not just at the beginning. And we're looking for some character followed by a different character, which we're saving, and then matching the second character and then the first character. That seems pretty good. That seems correct. Let's try just printing something here. Print returning early. And we can see if that ever happens. If it doesn't, then we've... Yeah, okay, it does. So it happens a lot that there are hypernet sequences with those, with that. Interesting. I just noticed that when I switch windows like that, it temporarily like shrinks the size of my code window, but not the Emacs window. Weird. All right. Well, maybe that's just a thing that OBS preview shows up and it looks fine to you guys. I don't know. But okay, so what I'd like to do now, we guessed 117. Let's make sure that we read the instructions correctly. We've had trouble with that in the past. If it has an ABBA, it supports TLS. It's a 4-character sequence, a pair of 2 different characters, followed by the reverse of that pair. But it has to not have any ABBAs within square brackets. So let's try running. Yeah, I know you guys couldn't see when I was looking at the screen. Too bad. Looking at, I should say, at the web page. Let's try writing map accepts TLS over a list, and we'll just pass in all of the samples here. All the things that are in the sample inputs. You'll just have to take my word for it that that's what I'm copy and pasting from. Okay. Oh, that's the square that we wanted. Close, close, close. Let's in fact filter instead of map. Oh, of course. Filter accepts TLS of that. How does that look? Empty. What? Oh. Because we forgot to parse the parts out of it. Python compose functions. Is there like a built-in function composition or something? I'm gonna guess no. No, it's like, here's how you could write function composition in Python. Because I'd really like to compose the two functions. IP parts and accepts TLS. But I can't. So instead I have to write a lambda. No, Guido hates lambdas, but you're making me do it, Guido. Lambda s to return accepts TLS. Is it called accepts TLS? Yeah, it is. Return accepts TLS of IP parts of S. Invalid syntax. Where? Why? Oh, I can't put a return in the lambda there. It's implied. So 3 of them return true. And that is incorrect according to just the... Yeah, okay. So which one is wrong? ABB, MNOP, yes, is supposed to. ABCD is not supposed to, and we got that right. AAAA. So this one is wrong. The way that we're attempting to correct for... Attempting to detect, I guess, would perhaps be a better way to say it. Repeating the same character 4 times is not working. So that's interesting. So we can test that with contains ABBA of this. And that's true. Why? Maybe we actually do need these? I don't think that's right. No, making that change broke everything. Okay, well, what do you think, Perl? Help me out here. Perl printf m slash this AAAA. Perl prints. So I'm clearly wrong about something again. Any character followed by something which is not the previous character, I thought. What? PCRE back reference look ahead. Regex tutorial here. Why don't you guys have a look at this? Positive and negative look ahead. We want negative look ahead is what we're trying to do, right? Oh, is this the problem, that I did this? Yeah, that is the problem. I always forget the syntax for the various kinds of look ahead, the look around, I should say. Yeah, that's what it was. We had an equal sign where you guys couldn't see that. Here you go. We had this equal sign here. Dang it. There we go. I'm having trouble highlighting. It's this one. Is not the right syntax. So we were matching any character followed by something which is not an equal sign followed by that same character. Of course, there were no equal signs, so this clause was never triggering. So we just need to go remove this and run Python again, and we should be good. 110. So there were 7 false matches that we were incorrectly accepting, and now we have the right answer. Lovely. Part 2. You would also like to know which IPs support SSL, super secret listening. An IP supports SSL if it has an area broadcast effect accessor, ABA, anywhere in the SuperNet sequences. Oh wait, which ones are the SuperNet sequences? I think it just told me, but I got lost. Oh, right. The ones outside of square brackets are SuperNet. Inside are HyperNet. All right. Whoa. Okay. So this is more interesting. It has an area broadcast accessor. Yeah. So it's an ABA outside of square brackets and a corresponding BAB inside of the square brackets. Okay. That's more interesting. So we can't just handle each segment independently anymore. So I think that what we need to do is we need to write another function that, well, first of all, is, does re.search return like an iterator? If I look at the things in it more than once, are they going to go away? Let's say x equals re.search for a in, let's say a, b in AB. X is just a match object, x0. X, wait. Has no attribute get item. How was I using re-search? Contains. I'm calling 0 on it here, aren't I? Huh. Bool of x? True. Type of x is a match object. Ah, no, wait. We have an IP port. Ah, and we're not actually, okay. We're not actually looking at its pieces at all. We're seeking over, that is to say iterating. I'm used to Clojure, where seek is a way to iterate over things. We're iterating over the results of splitting, but we're doing that with like filter. The results of this ABA search we just treat as a Boolean. So if I were to write x.next, how do you get stuff out of a match object? Are you guys looking at this? You're probably not, right? Yeah, I forgot again. Welcome back. I couldn't figure out. I was trying to figure out how you access the parts of a match object. Python match object groups. So if you get a match object, what is this? Yeah, array.match. Groups returns a tuple containing all the subgroups. All right, that's pretty good. That's pretty much all we wanted, right? Yeah, okay. We just call groups. Groups of X. Rita groups of X. Let's redefine X again. X.groups. We did it! Okay. And if I call groups again, will I get them again? I will. Okay. So, all we need to do then is we write a function that... So, here is an example of something that So earlier, before we implemented all this stuff, I was thinking about maybe we should turn the line into a class that holds like A, a list of the hypernet sequences, and B, a list of the supernet sequences. And I couldn't see how that was going to be more useful. It seemed like most of the part 2s we could run into would not make that helpful. But it turns out that here it actually would be. It would be useful to do that. Because then we could just iterate over all the supernet sequences, collecting the things to look for in the hypernet sequences, and then iterate over the hypernet sequences, looking for those things. So maybe we will make that change. But first, I'm going to git add git commit -m day 7 part 1. And let's see about maybe making that, because it's going to be a lot simpler to do it if we have things split up that way. And you know what? This episode's been going on for a while. I think that I'm not sure how long part 2 will take. Hopefully not too long. But I don't want this episode to continue for more than an hour. So I'm gonna declare an end to this episode, and I'll upload a second episode. I don't know, probably later in the day or something. But anyway, not too long after this one. Thanks for watching, and I'll see you next time.